Hey guys, this is Professor Roldan. For those of you watching this as a review, I hope you enjoy this time together as we go over various questions from College Algebra, Chapter 3. We're going to be analyzing polynomials, quadratics in particular, and regular polynomials, third degree, fourth degree, so on and so forth. So let's get started here with our review that I have posted already with the answers. So we're just gonna be able to talk about this together here, and hopefully I answer most of your questions, and if not, feel free to email me what they are. All right, let's get started. Okay, so first of all, we're going to analyze a quadratic function. So this is power of 2. And we have various aspects to cover here. And this one is already shown here on the graph, and all we're going to do is identify the different parts. So make sure you answer all the different parts here. So A is the vertex, and that will be right there. As you can see, that is 2, 2. And next we have the axis of symmetry, so that would be the x-coordinate of that vertex. And then our x-intercepts. And as you can see, usually that would be the most work, but in this case we do not have anything to show, and so we're going to be basically answering that there are no x-intercepts, so we can just put none. It's fine. Whoops. Okay, there are no x-intercepts, and if you were calculating this in a different scenario, you would get imaginary numbers. Okay, imaginary numbers would signify no x-intercepts. All right, so this is letter D now. So the y-intercept is always found by f of 0. That's basically right there. That's the y-intercept, which is 0, 6. Okay, and the last thing is, what is the equation of this function? Okay, so remember, vertex form looks like this. So h squared plus k. All right, and so we're going to be answering and saying, well, we have everything we need. We're not going to worry about the A necessarily. We can kind of see that it's a 1, but in this case we're just going to write x minus 2 squared plus 2. Okay, so not so bad when the graph is already given. We can just start identifying things. So now let's go to one where we do not have the graph, and we have to produce all this information ourselves, and then last of all graph it. All right, so let's go to number 2. Number 2, here's the equation, and so we can quickly identify the h right here and the k right here. So h would be 2 and k would be negative 6. And so A, the vertex, is going to be so h and k, which is the vertex, is going to be 2, negative 6. And the axis of symmetry is going to be the x-coordinate of that. Okay. And then C would be the x-intercept. So this is where most of the work is going to happen. So remember, the definition of an x-intercept is basically what is x when y is 0. So remember, y and f of x are interchangeable, so basically that's going to produce this scenario. So we're going to make f of x equal to 0. We have our function here, and we go ahead and solve for x. So we want to divide by 3, so we can isolate this. Alright, so you could actually FOIL this, but that would take much longer, and then you have to factor and set it equal to 0 and all these things. So the best way to approach this problem is to go ahead and do the square root of both sides. That's going to cancel out the power of 2. But since we don't get a perfect square on the left side, this was unintentional. So unfortunately, we're going to have a decimal over here, which is okay. But I'd rather not put a decimal on the test. So let's see what we get here. X minus 2 on the right, and then plus or minus the square root of 2 on the left. Okay, and then we're going to add 2 to both sides. So our final answer here is going to be, in exact form, will be this here. Okay, but since we do want to graph this eventually, we do want to know what the x-intercepts are. Still, we want to go ahead and take it a step further and get the decimal format of that. So 2 plus square root of 2. Square root of 2 is about 1 point something, so that's going to be 3.4. Okay, so 3.4 is the first one, and then if you do 2 minus 1.4, you're going to get 0.6. Okay, so don't really need those on a test as they produce decimals, but now we can actually graph those. But we're going to go ahead and continue here. So that's A, B, C, and D. The y-intercept, that is, what is y when x is 0? So we're going to just do f of 0 equals 0 minus 2 squared minus 6. So that's going to be 4. And then 12 minus 6 would be 6. Okay. So that basically gives us all the information we need. We have the vertex, that's a point. We have the axis of symmetry. We have these 2 points to plot, and this one here. So that's 4. Let's take a look, see what it gives us. So 2, negative 6 be about right there. Then 0.6 will be around right here. 3.4 will be about right there. And then the y-intercept is 6, so that'll be right there. And so we can just do a quick sketch here. Bounce, Go up there. All right. And if you want to do an extra point, that's fine, using the axis of symmetry. So this point would be right there. Okay, but that's optional. Okay, so again, for the test, you're not going to get a situation where you get decimals for x-intercepts. So don't freak out about that. But it's possible on, it's in different situation, it is possible. So that is A, B, C, D, and E. E is right here. Okay, well, let's move on to another question here in a different format. So here, this is vertex form, where you can actually see the vertex. Now we're going to see it in standard form, where you can't see really anything except for the y-intercept. So let's see what it looks like. Okay, so number 3 is in standard form. And the only thing that's kind of visible is the y-intercept, and you can kind of see it right there. But we're going to go ahead and get started with A. So, since we can't see the vertex, we're going to use the formula for the vertex. And that's starting with the x coordinate. And that's going to be -6 over 2 times 1, which is -3. And then we're going to take that -3 and plug it into our function, so we can calculate the value of this function at this spot. So 9 minus 18 plus 8. So that's -9 plus 8, which is -1. So final answer for A, the vertex, is -3, -1. Okay, let's go to B. Axis of symmetry is just going to be the x coordinate of this. Alright. Now, if you want to start plotting stuff, you can. So we're going to take the vertex as -3, -1. Which is right there. And we can do a nice axis of symmetry. Now we need the x-intercepts. And the x-intercepts again are found by making the equation equal to 0 and solving for those x's. In this case, we don't need the quadratic formula because these can be factored. So x times x is x squared, and then what times what is 8, but adds up to 6. That would be +2 and +4. And so then these are each equal to 0. Oh, I think we stopped doing that after a while. So this is going to be -2, and this x is going to be -4. Okay. And if you want to do the coordinates, that's fine as well. It's not really necessary. So we can come over here and graph these. -4 is right here, and -2 is right here. As you can see, they're equal distance from that axis of symmetry. Okay, another good piece of information would be the y-intercept. So we know where to cross that y-axis, and then we can use symmetry to draw the other side. So y-intercept would be f of 0, which I already said we can see that from the beginning. So that's going to be 0 plus 0 plus 8, which is 8. So we just make this. Now, this left side, just try to make it reflect very good, like a mirror. If not, you can use symmetry. So it's 1, 2, 3, 1, 2, 3, right there. And that way we have a little bit better accurate graph there. Okay. And then this is E. So vertex, axis of symmetry, x-intercepts, y-intercept, and the graph of the function. Okay, our next section would be number 4. We're still working with quadratics here, as this is asking for maximum and minimum value. Okay, so remember, minimum value happens when the quadratic is open up, and open down will create a maximum value. So all you got to do is look at the end behavior. And the end behavior of this function, the leading term is a negative x squared. So that tells us that we have a even function, which is positive, or sorry, negative. That means it's going to be like this. But since this is quadratic, we know what this looks like. So that's definitely a max. Now, where is this max? We do have to calculate that. So this is going to be positive 2 over negative 2, which is negative 1. So this goes into our function, and we get, don't forget all these different negatives everywhere. So this is negative 1 plus 2 minus 8. Which is negative 7. Okay, so that maximum value happens, the coordinates would be negative 1, negative 7. Okay. So number 5 and 6, basically we have, and 7 and 8, we're going to answer yes or no. Okay, so determine whether the function is a polynomial function. All right, and having a fraction as a power, that tells us that that's not going to be a polynomial. And having a fraction as a coefficient, that is okay. Okay, the fraction just can't be as a power of x. So a fraction as a coefficient is fine. So yes, that's a polynomial to the 7th power. Polynomial functions are smooth, no breaks and no corners. And if you look at this, this is smooth. So yes, it is a polynomial function. No breaks, corners, etc. Okay. Let's take a look at number 8. And there's definitely a vertical asymptote here. Okay. And so this is not a polynomial. So vertical asymptote not a function. Not a polynomial function. All right, now we have number 9. In number 9, it just wants to know end behavior. So end behavior is basically right there. You're looking at the leading coefficients. And because that is a positive, so it's odd, and it's positive, so it's going to be basically like this. And the only one that looks like that would be D. Okay, so there's my end behavior right there. Okay, now if it would have been negative, then we would have chosen A. Okay, and if it would have been even, then we would have looked at C or B. Okay, let's take a look at number 10. So the end behavior there is even and positive, so they're both going to be going up. Okay, and we can see that right there, as we have our end behavior both going up. The left and the right are going up. Okay, let's take a look at number 11 and 12. 11 and 12 just wants to know what the zeros are. Okay, so remember, you want to set these equal to 0. That's the definition of a 0. And that x right here is a -5, and this x right here is a +2. Okay, so those are your zeros right there. And number 12, it's not set up for you, so you have to go ahead and factor this. And so we're going to try to do grouping instead of doing synthetic division and whatnot. We're going to just try to factor it. So this one's factorable because if you look, the GCF of group 1 is x squared, which produces x plus 5. And if you take the GCF of group 2, which is -4, that's going to produce another x plus 5. So this is definitely factorable because those match, and since they match, they come out as another GCF. And then we have x squared minus 4 right there. And this can be factored further. Since that's a difference of 2 squares, positive 2 and negative 2. So we have a 0 right there. Whoops, I forgot my zeros there. So okay, and those are my 3 zeros. Okay, so now we want to know not only the 0, but we want to know the multiplicity and if it touches and turns or crosses. So if we look, so there's a 0 right here and a 0 right there. And the multiplicity, you look at the power. So this is a multiplicity of 1. And that means it's going to cross. And this one's a multiplicity of 2. And that means it's going to touch and turn, or I like to call bounce. Okay, so we just look for the right answer for that. So negative 2 is a cross. So there's negative 2, there's the cross right there. And negative 5 is multiplicity of 2, touches and turns or bounces, so that will be A in this case. Okay? Alright, let's go to the next page. So this time we're going to find the zeros and then go ahead and determine whether it's going to cross or if it's going to, the multiplicity, which tells us if it crosses or if it bounces. All right, so let's see. Number 14. This doesn't have 4 terms, so we can't do grouping, but it does have a GCF in all 3 terms. So we can do a GCF, and that GCF is going to be x. And what's left over is x squared plus x minus 20. And this is the part that can be factored. So factors of negative 20 that add up to 1, or subtract to 1 actually. So we're going to do positive 5 minus 4. So positive 5 times negative 4 is negative 20. 5 minus 4 is 1, so we are good. So here is x equals 0, x equals negative 5, and x equals 4. Okay. So for x equals 0, multiplicity of, we just look at the power, and it's 1. So that means it crosses the x-axis. X equals negative 5. We can see the power is 1. So it's multiplicity of 1, which also means it crosses. And x equals negative 4 also has a power of 1. Okay. So that is it for number 14. Let us go to synthetic division in number 15 and 16. Okay, so remember we want to use the 0 of that binomial, of that factor. So we want to use x equals negative 7. So negative 7. And make sure this is in descending order, which it is. 2, 1, and then constant. So we're going to just go ahead and place 1, 16, and 61. So we'll bring down the 1, multiply by negative 7. Combine 16 and negative 7, which makes 9. Negative 7 times positive 9, that's going to be negative 63. 61 minus 63 is negative 2. Okay, so this is our basically our remainder, our constant, and our x to the first power. So we're going to translate this into x plus 9 minus 2 over the binomial x plus 7. Okay? That's number 15. And number 16, again, we're going to use the 0 of that. So that's going to be x equals 2. Now, there's a lot of stuff missing here. So there's an x to the fourth missing, and there's actually 2 more terms missing right there. So we're missing x to the fourth, x to the, which means it's a 0, x to 0, x to the second, and 0x. So which means we have a lot of filling in to do. So we're going to do 2 into 1. That's x to the fifth. X to the fourth is missing, so it's x 0. X to the third is there. And the next 2 are missing, so we're going to put 0, 0, and then finally the negative 5. So we're going to bring down the 1. 1 times 2 is 2. 2 plus 0 is 0. I'm sorry, 2 plus 0 is 2. 2 times 2 is 4. That's going to make 5 there. 2 times 5 is 10. 10 plus 0 is 10. 10 times 2 is 20. Bring down that. And then 2 times 20 is 40. And that's going to give us 35. Okay, so this is going to be our remainder, our constant, our x, x squared, x to the third, and x to the fourth. Okay? So we're going to take this and translate it to our answer, which is going to be x to the fourth plus 2x to the third plus 5x squared plus 10x plus 20 plus 35 over the binomial x minus 2. Okay, so synthetic division is great for finding the next polynomial and including any remainders. But from now on, we're not going to get any more remainders because we want to get zeros and find the rest of the zeros. So let's take a look at 17. Okay, so number 17 says, use synthetic division to divide that polynomial by x plus 8. Use the result to find all zeros of f. So we're going to use negative 8. So negative 8 into, and we don't have any missing terms, so we're going to put 1, negative 1, negative 52, and 160. So we're going to bring down the 1, multiply the negative 8 times that result, which is going to be negative 8. Combine negative 8 and negative 1, make negative 9. Multiply negative 9 and negative 8, that's going to give us positive 72. We're going to subtracting it 20, negative 160, and there's our 0. Okay, so we need to use this as our remaining polynomial. So basically now we have so x squared minus 9x plus 20. And we factor those two, which is going to give us x and x, and 4 and 5. So 4 times 5 is 20. 4 plus 5, that's not negative 9. So I need negatives in there. Okay, so the zeros of this would be all of these x's here. Negative 8, 4, and 5. Okay, those are all your zeros or your x-intercepts right there. Now we're going to do the same thing for number 18 because so instead of giving us a binomial, they just gave us a 0, which is negative 3. Okay, so we have to create our binomial from this. So we're going to do, so 3, 2, 1. Okay, so nothing's missing. Go ahead and put these in here. Just 3, negative 9, negative 4, positive 12, so that's 0. Alright, so there's our remaining polynomial. So this is going to produce x plus 3. And then we have x squared plus 3x minus 4. And we factor these guys. Positive 4 minus 1. Because 4 times negative 1 is negative 4. 4 minus 1 is 3. So we're good to go there. Now we have our zeros right there, there, and there. Okay. Now, let's practice a little bit rational zero theorem, which is starting off with no clues at all. So when you have no clues, and what I mean by clues is over here, the clue was this binomial, which means you're going to use negative 8 to test, and we got the no remainder. Here the clue is negative 3. We test it out, and we get a remainder. Okay? So here we have no clues. So the clues come from the formula P over Q and that's just basically saying the factors of 21 over the factors of 1. And because factors of 1, there are none except for 1 in itself, all we got to do is focus on the factors of 21. So if you look, we're going to get plus or minus the factors of 21. And there they are right here. 1 times 21, 3 times 7. Okay, and down here we have P over Q, which is going to be factors of 2 over the factors of 7. So it's plus or minus 1 and plus or minus 2. This one's plus or minus 1, plus or minus 7. So now we divide each of those. So a possible rational 0 would be, or x-intercept, would be this 1. So 1 divided by 1, that's going to be 1. And then 1 divided by 7, that's 1/7. 2 divided by 1, 2 divided by 1 is going to be 2. And 2 divided by 7 is going to be 2 sevenths. And they don't have to be in the same order, but those are basically your possible rational zeros. Okay, so we've reached the last page, our last couple questions here, where this puts all the skills together as we try to graph a polynomial from scratch. No clues, we just got to look and see what we need to do here. So the guidance that you're going to get is basically figure out the end behavior, x-intercepts, and the multiplicity, and the y-intercepts. That's going to be basically everything you need to do a sketch of this graph. So let's start with end behavior. So end behavior for A, make sure you fill out each of these spots as they are worth points. The end behavior is the leading coefficient, which is x to the 4th. As we can see, this is not only even, which means the arrows go in the same direction, but they're positive. So they're both going to go in the upward direction. Okay, so that's what the end behavior is for this function. Now let's go to x-intercepts. Now, because you want to look at the function and ask yourself, is this factorable? Because if it is, like this one, in this case, this is a yes, this is factorable. So no need for rational zeros. Okay? No need for rational zeros. We just factor. If it's factorable, we factor. And again, let's see, it's supposed to be a 4 right here. Okay, so we set it equal to 0, and we do a GCF factoring. They both have an x squared inside here. So once we factor out the x squared from both terms, we get x squared minus 4. And then this can be further factored into an x and x minus 4 plus, minus 2 plus 2. So now we have a 0 right there, right here, it's positive 2, and this one's negative 2. Now, taking a look at the multiplicity, you can tell this is a 2, that's even multiplicity. So that's going to be a bounce or a touch and turn. And both of these have a power of 1, so those are going to be both crosses. Okay. And then last of all, let's take a look at our y-intercept. So the y-intercept is basically f of 0. And f of 0 just means you're going to plug in 0 in both x's, which means you get 0. Okay. So now let's put everything together here. So we have an x-intercept at 0, which also is the y-intercept. So those two are the same. We have a 2 and a negative 2. So here we have a cross, and we have a bounce here. And we know the end behavior is going in the same direction. And they're both going up. Okay. So this means that as we draw this, we're going to cross that -2, and then we're not going to cross the y-axis. We're going to come back up, hit this 0 and bounce, or touch and turn. And then we got to go back up and cross because our end behavior says we got to go up. And there it is. Okay? So all the clues that we just found, end behavior, x-intercepts and their multiplicities, which tells us that they bounce across, and then the y-intercept gives us all the clues we needed to get this thing graphed. Okay, so you're going to get points for your work and separate points for your graph. Let's take a look at number 22. Number 22, if you can see that it has 4 terms, but you can't, if you try to cut it in half and try to group it, you're not going to get common factors from both of those as far as the binomials are concerned. So this is not factorable. So when things are not factorable, then we need to go and say, well, I have no clues, so I need to go ahead and use rational zeros for the x-intercepts. But before we do that, let's go ahead and answer end behavior. Leading coefficient is x to the third. So we can see that it's odd and that it's positive. So that means that our graph is going to rise to the right and fall to the left. Okay. That'll definitely help us later. And since this is not factor, I can't really set it equal to 0. I need to test out rational zeros. So factors of 6 over factors of 1. And because factors of 1 it's not going to affect the factors of 6, we can go ahead and just write the factors of 6. So the factors of 6 would be 1 times 6 and 2 times 3. Okay? So those are our options. Okay, this is basically a guessing game, but we've now limited our options to 8 numbers: positive 1, 2, 3, 6, and negative 1, 2, 3, 6. And hopefully, when we test out the first one, it's going to work, so we can stop guessing. All right, so let's go ahead and try positive 1. And we're not missing any terms, so we're going to put 1, negative 2, negative 5, and 6. And hopefully we get a 0 at the end for our remainder. So let's go ahead and start. 1 times 1 is 1. That's going to be negative 1. Negative 1 times 1 is negative 1. It's negative 6. And yes, it works. So great, we don't have to keep testing negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, and negative 6, because we've already found that 1 is going to work. And since it works, x equals 1 is an x-intercept. And since it's an x-intercept, then we're going to do this. Okay, there's that 1 sitting right there. And now we can use our results here. So it's x squared minus x minus 6. And factors of negative 6 that equal negative 1 would be negative 3, positive 2. So there's your 1 that we already found from the synthetic division and testing out possible zeros. And this one's going to be now 3, and this one's going to be negative 2. And so since we can look at the powers, they're all odd, which means they're all going to cross. They have multiplicities of 1, so that's going to cross. And now let's go ahead and put in, oh wait, we need a C, which is our y-intercept right here, which is f of 0, which is going to be 0 minus 0 minus 0 plus 6 equals 6. Okay, so let's graph this thing. Y-intercept right there, that's 6. We have a 1, we have a 3, and we have a, it's supposed to be negative 2, sorry. This is supposed to be negative 2, so right there. And our end behavior says it should be down here on the left side. On the right side, it should be going up. So now we just fill in the blanks. So we need to go from our end behavior, cross, come back down, cross, and somewhere turn back up and cross again. Okay, so that's a cross, cross, and a cross. And there you have it. A nice little sketch without using calculus to find the graph of a polynomial. And we are good to go. So this is starting from scratch using possible rational zeros. We tested out 1. And that helped us find the rest of the zeros. All right, let me know if you have any questions, and we'll see you in class.